Greetings to everyone. Today we are going to discuss about the topic of thin cylinders and related problems. Okay, so earlier onwards we have discussed that the problem related to thin cylinders. Okay, some formulas and if because of internal pressure, what are the changes in the dimensions that also seen yesterday. So related to that we will see some problems. Okay, here. Now let us write the question paper. Thin cylinder problem related to changing dimension. So problem. So the given data is a cylindrical vessel whose a cylindrical vessel whose ends are closed by means of rigid flange. Rigid flange plates is made up of is made of steel plate 3 mm thick. The length and internal diameter. The length and internal diameter of the vessels are 50 centimeter and 25 centimeter respectively. Determine the determine the longitudinal and hoop stress hoop stresses in the cylinder in the cylindrical shell due to an internal pressure due to an internal fluid pressure of 3 Newton per mm square. Also, also calculate the increase in increase in length, diameter and volume of the vessel. Take Young's modulus E of the material is equal to 2 into 10 to the power 5 Newton per mm square and Poisson's ratio mu is equal to 0. So these are all the given data. So we should list out the given data now. So given data. Okay. So they have given that by means of rigid plates of steel plate 3 mm thickness. Okay. So thickness of plate is equal to 3 mm. Next, the length and the internal diameter are 50 centimeter and 25 centimeter. So the length L is equal to 50 centimeter which is 500 mm, and internal diameter 25 centimeter, which is 250 mm. So next to that, they have given determine the longitudinal and hoop stress if the fluid pressure small p is equal to 3 Newton per mm square, and they have given that E value is equal to Young's modulus is equal to 2 into 10 to the power 5 Newton per mm square, and Poisson ratio mu is equal to 0.3. Okay, now these are all the given data. Then we have to find hoop stress, comma longitudinal stress, and change in dimension, diameter, change in length, and change in volume. So these things we need. So let us move on to the solution part. So first of all, we all know that hoop stress formula. Hoop or circumferential stress. Sigma 1 is equal to PD divided by 2 times of thickness. So P is equal to 3 and D is equal to 250 mm divided by 2 in thickness equal to 3 mm. So if we are going to substitute this, we can get the value 3 into 250 divided. So 125 Newton per mm square. Sigma 1 is equal to 125 Newton per mm square. Next, we should move on to the longitudinal stress. Longitudinal stress, that is sigma 2. So sigma 2 is equal to PD divided by 4 times of T. So P value is 3 and D equal to 250 and 4 into thickness is 3 m. So 250 divided by becomes 62.5 Newton per mm square. So sigma 2 value is equal to 62.5 Newton per mm square. So this is the value of longitudinal stress. So next we should move on to the change in dimensions. Okay. So we should move on to the change in dimensions. So here, first we all know that circumferential strain. Circumferential strain, that is E1 is equal to E1 is equal to sigma 1 divided by E minus mu into sigma 2 divided by E. Okay, so the circumferential strain E1 is nothing but the change in diameter divided by original diameter. Okay, so from this we can directly calculate the del D, that is change in diameter. So sigma 1 value we have calculated that 125. So 125 divided by 2 into 10 to the power 5 minus mu value is 0.3. Mu value is 0.3 into sigma 2 is 62.5 divided by 2 into 10 to the power 5. Therefore, sigma 2 becomes, sorry, E1 becomes, so 125 divided by So the value is 0.000531. Okay, that is the circumferential strain. Therefore, change in diameter, change in diameter, that is del D becomes the value 0.0531 multiplied with D. So we all know that D is equal to 250 mm. Therefore, change in diameter becomes 1328 mm. 0.1328 mm. So this is the change in diameter. Similarly, next I'm going for the longitudinal strain. Longitudinal strain, which is nothing but E2. So the E2 is nothing but change in length by original length. Then the formula becomes sigma 2 divided by E minus mu into sigma 1 divided by E. So if I am going to substitute these values, 62.5 into 10 to the power 5 minus 0.3 into 125 divided by 2 into 10 to the power 5. Then the value of E2 becomes del L by L. So L value is nothing but 500 mm. So 500 mm is equal to, what is the answer? So 62.5. So it becomes 0.000125. So therefore, change in length becomes answer multiplied with 500. So it is nothing but 0.0625 mm. So this is our change in length value. Okay. So still we can have another thing, that is volumetric strain or change in volume we need. Okay. So volumetric strain, that is del V by V. Okay. So this is nothing but we can have one formula, uh, that is 2 into E1 plus E2. Okay. So what is E1 value and what is E2 value, that we have to apply right now. So 2 into E1 is 0.000531, 0.000531 plus E2 value is 0.00125, 0.00125. It becomes, so 0.001187 is the volumetric strain value. Okay. So here we need change in volume. So change in volume del V is nothing but 0.001187 multiplied with original volume. Okay. So the original volume V is equal to pi by 4 into D squared multiplied with L. So pi by 4 into D squared, 250 squared multiplied with 500. It becomes, so the value of volume is equal to 24.544 into 10 to the power 6 mm cube. Therefore, change in volume is equal to 0.001187 multiplied with this answer, it becomes 29,133.36 nm cube. So this is the our value of final answer. Okay, so like this we have to calculate the change in, that is circumferential stress and longitudinal stress, then change in diameter, change in length, and change in volume. Okay, this is about the first problem. Next, second problem. So problem 2. So the given data is like that. A cylindrical vessel. So all are direct formula substitution only. So little bit the indirect statement is available. Okay, based on that statement, we have to find out the remaining things. Okay, a cylindrical vessel is 1.5 meter diameter and 4 meter long, is closed at ends by rigid plates. By rigid plates. It is subjected to an internal pressure of 3 Newton per mm square. If the maximum principal stress, if the maximum principal stress is not to exceed 150 Newton per mm square, then find the thickness of shell. Find the thickness of shell and assume Young's modulus E is equal to 2 into 10 to the power 5 Newton per mm square, and Poisson's ratio mu is equal to 0.25. Also calculate change in diameter, length, and volume of the shell. Okay, so with respect to this problem, the given data are, so the cylindrical vessel of diameter, so D is equal to 1.5 meter, which is nothing but 1500 mm, and 4 meter long, so 4000 mm, and it is subjected to an internal pressure P is equal to 3 Newton per mm square. The maximum principal stress is not to exert. The statement maximum principal stress is nothing but sigma 1. Okay, so if the sigma 1 is not to exceed 150 Newton per mm square, then what is the thickness of the shell required? That we have to find out first. Okay, then they have given that E is equal to 2 into 10 to the power 5 Newton per mm square. Then Poisson's ratio mu is equal to 0.25. Now we have to calculate T is equal to how much, then change in diameter, change in length, and change in volume is equal to how much. These are all the things we have to calculate. So let us move on to the solution part. So they have given the maximum principal stress, that is sigma 1 should not exceed 150 Newton per mm square. So by using that, we have to find out the thickness value. Okay, So we know the formula of sigma 1 is equal to PD divided by 2 into T. So which is equal to 150 Newton per mm square. Here pressure value they have given us 3 Newton per mm square, and diameter they have given us 1500 mm divided by 2 into T is equal to 150. So which implies thickness required is equal to, so it becomes 15 mm. So the thickness of flanges or plates we have to give as 15 mm. Okay, then it can withstand the maximum pressure of 150 Newton per mm square. Okay, next we should go on to the further, that is change in length, change in volume, and change in diameter. Okay, so we know the formula, we know that. Okay, uh, change in diameter del D is equal to PD square divided by 2TE into 1 minus mu divided by 2. Okay. Here substitute all the things. So pressure P is equal to 3 Newton per mm square. D is equal to 1500 mm square, and 2 into thickness is 15 mm, and E is equal to 2 into 10 to the power 5 into 1 minus mu value is 0.25. So 0.25 divided by 2. So if I am going to substitute this, I can get the value of change in diameter. So 0.984 mm is the answer. 0.984 mm is the change in diameter. So next we should move on to change in length. So change in length del L is equal to PDL divided by 2TE into mu, that is 1 by 2 minus mu. Okay, so if I am going to substitute here, 3 into 1500 into 4000 divided by 2 into thickness is 15 into 2 into 10 to the power 5 E value. So 1 by 2 minus mu 0.25. So, so 0.75 mm is the value of change in length. Okay, next we should move on to change in volume. Okay, so change in volume. So here we are going to use the formula del V by V is equal to 2 into E1 plus E2, whereas E1 is equal to del D by D plus E2 is nothing but del L by L. So if I am going to substitute this, 2 into del D value is 0.984 mm. So 0.984 divided by D is 1500 plus del L 0.75 divided by 4000 mm. So if I'm going to substitute this, so 0.0015, okay, mm sorry, this is no unit. Okay, so this is the value for volumetric strain, that is change in length by original length. So I have to multiply the given value with original volume. So original volume V is equal to pi by 4 into d squared into L. So pi by 4 into 1500 square multiplied with 4000. Therefore, change in volume is equal to change in volume del V is equal to that value 0.0015 0.0015 into original volume value. So here original volume value is pi by 4 into 1500 square multiplied with 4000. So it becomes 7.068 into 10 to the power 9 mm cube. Therefore, the value is multiplied with 10599340.9 mm cube. So this is the change in volume answer. So this is the answer for the second question. That is, they have given the maximum principal stress value. So from the principal stress, we have calculated the value of thickness. Okay. From the thickness, we are going to find out the remaining things. That is change in length, change in diameter, and change in volume. So like the way we have our similar problems. Okay. Now let us move on to the another problem. A hollow cylindrical drum 600 mm in diameter and 3 meter long has a shell thickness of 10 centimeter, sorry, 10 mm. Shell thickness of 10 mm. If the drum is subjected to if the drum is subjected to an internal pressure of 3 Newton per mm square, calculate the increase in its volume. Take E is equal to 2 into 10 to the power 5 Newton per mm square, and the partial ratio mu is equal to 0.3 for the material. So let us move on to the given data. So they have given that cylindrical drum diameter D is equal to 600 mm and the length is 3 meter. So 3000 mm has a shell thickness of 10 mm. So T is equal to 10 mm. The drum is subjected to an internal pressure P is equal to 3 Newton per mm square. Okay. So next they have given that E value equal to 2 into 10 to the power 5 Newton per mm square and mu is equal to 0.3. So we have to calculate increase in volume. So increase in volume we have to calculate. Okay. Solution. So we all know that change in length, change in volume by original volume. Okay. So we have one formula, that is change in volume, it is volumetric strain. Volumetric strain del V by V is equal to, we had one formula while deriving, we have done P by D into 2TE into 5 by 2 minus 2 times of mu. Okay. So we are going to substitute in this formula. So P value is 3 and D value is 600 mm, 600 mm by 2 into thickness is 10 mm into 2 into 10 to the power 5 of E value, sorry, 5 by 2 minus 2 into mu value is 0.3. So if I'm going to substitute this, I can get the value of volumetric strain. So 3 into 600 divided by into 2 so 5 multiplied with 5 by 2 minus 2 times of mu. So it becomes 8.55 into 10 to the power minus 4. So it becomes 0.000855 is the value. Then actually I need change in volumetric, change in the volume. Okay. So change in volume del V is equal to whatever the value we got is multiplied with original volume. So here the original volume is pi by 4 into d squared into L. So pi by 4 into d squared into L, 3000 mm. So it becomes 848.23 into 10 to the power 6 mm cube. Therefore, the change in volume del V is equal to multiplied with 0.000855. Then it becomes 7,25,236.66 mm cube. So this is the answer for our change in volume. Okay, thank you all.